The purpose of this demonstration is to show the capabilities and qualities of directional antennas. I'm using 6-inch flat panel antennas for this demonstration. These are a little bit smaller than the types of antennas we would normally use. Antennas that we would normally use would be at least 1 foot flat, maybe even larger, or parabolic dishes. But they all have the same sorts of qualities. How I've mounted these, I've got 2 radios in front of me. I have 2 radios, a 100 base T Tsunami and a 10 base T Tsunami radio, operating in the same band, and they're hooked up to these 2 antennas. If we look at the back of the antenna, the backs of the antennas show the polarization settings for these antennas. This one here shows the arrow going left and right, representing horizontal polarization. And here we have the arrow going up and down, representing vertical polarization. So these 2 antennas are oppositely polarized and faced roughly in the same direction. So we'll spin these antennas back around, and we'll go to the other side of the link, and we'll demonstrate the performance of these antennas. On this end of the link, we have a flat panel antenna, this time a 1 foot flat panel, hooked up to a spectrum analyzer. The spectrum analyzer is set to sweep between the frequencies that the radios are transmitting on the far end of this link. This antenna can be changed in different polarizations, and we can move it around to illustrate the angular discrimination and the polarization discrimination of these type of antennas. So next we'll show that. Now, aiming at the other end of the link, we can see that when I hold the antenna in this fashion, we see one of the transmitters. And when I move the antenna left and right, we see the signal rise and fall. There is probably the main beam of the antenna. It'll fall and rise again. And these are the side lobes of the antenna. This illustrates that when you're aligning antennas, you need to sweep them over a very wide range so that you're absolutely certain you're on the main beam. The same physical phenomenon will happen in the up and down plane. So the same rules apply there. Now, another thing we'll see is that if I rotate this antenna to the opposite polarization, we'll see the signal of the interfering signal rise and the signal of the other signal fall. And the idea here is that the polarization of the antenna by itself is discriminating between those 2 transmitters that are roughly on the same frequency, roughly on the same bearing. And I think I can better demonstrate that as I rotate and try to hold the antenna still and rotate it back. So this demonstrates the interference canceling capability of polarization. So when you take this interference canceling capability of polarization and combine it with angular discrimination, both left and right and up and down, you can imagine that you can create quite high density hub sites just using the capabilities and the discrimination of this type of antenna system.